Hi everyone, my name's Dean Lewis. I'm Technical Account Manager at VMware, and today we're going to be talking about the VMware Folding at Home appliance and our efforts to support the Folding at Home project. Just a little bit of background about myself. Of course, my career focus has been in virtualization, as you can imagine, working for VMware. Outside of work, I'm a keen scuba diver, and you can get in touch with me either through my blog, theeducate.co.uk, or on Twitter at StPLE. High level, we're going to be covering what the project is, what is protein folding, what are the outputs from the project, how to get involved, and then, of course, a little bit of a technical demo as well. So the Folding at Home project is a distributed computing software project for simulating protein dynamics, which we'll talk about a little bit more in a moment. Brings together volunteers from around the world to run the simulation of protein dynamics using their own personal equipment, their home labs, or in the case of, where possible, on their business equipment as well, as long as their employer allows them to do so. The insights from this data help scientists to understand the biology better, viruses and diseases, and provide new opportunities for therapeutics. The project itself was founded in October 2000. And of March 20th of this year, VMware released the VMware Appliance for Folding at Home to help support the project's efforts for those with vSphere environments. And first and foremost, I'd just like to start with a 60-second clip from our CEO, Pat Gelsinger, about our efforts to support the project.
Hi there, Pat Gelsinger here. I'm a firm believer that technology can and should play an important role in medical research, especially for fighting the COVID-19 pandemic. It's why Folding at Home is so exciting. In a grassroots example of our commitment to citizen philanthropy, over 1,000 VMware employees, partners, and customers joined Team VMware Folding through the globe. A few of our employees have gone above and beyond through our VMware Foundation's Good Gig program to strengthen the Folding at Home project by assisting in modernizing applications and creating a secure multi-cloud strategy. I'm so proud of the VMware community for coming together to take action for what they are passionate about. And thanks to everyone around the world who has been involved in this program by sharing your unused computing power. It's truly amazing to see such an outpouring of support. You can learn more at foldingathome.org. Thank you so much.
Okay, just to give it a little bit of context, VMware's ethos, as Pat mentioned, throughout the company is to produce technology for good. And for me, getting involved with the Folding at Home project is a real simple way to help contribute in the fight against not only COVID-19, which of course is affecting us all today, but other diseases such as Alzheimer's. We obviously believe that our individual actions add up to our collective impact. And as you probably heard the saying, big things have small beginnings. The VMware Folding at Home appliances really kind of encapsulates that quite well. It was a concept to a public fling in 72 hours, and that's our fastest release ever. So digging down into the scientific side a little bit, what is protein folding? A protein itself is the basis of how biology gets things done in the human body. As enzymes, they help drive our bodies, build structural elements such as bones, muscles, skin, and blood vessels, antibodies, which allow the immune system to get rid of unwanted invaders. What is folding exactly? So a protein takes a shape called a fold in the body. The image in front of you, we have the image of a folded protein on the right-hand side, and the Folding at Home project is looking for gaps whereby drugs can bind to a protein to help the body immune response and to fight diseases. It's very similar to putting the pieces of a very complex jigsaw together. And what are the outputs from the project? Today, there's already a number of papers which have been released from the research conducted by the project and the researchers that are involved. And these images in front of you, we're looking at the same protein whereby distributed computing scale of the project has allowed researchers to understand how this virus binds to our cells. For those of you who are fans of Stranger Things, this spike has been nicknamed the Demogorgon. And the researchers' aim now with this spike is to understand which drugs are available or can be created in the future which attack or bind to the opening of the mouth, the Demogorgon, to stop it from binding to our human cells. just finish off with some statistics. So folding at home does offer a little bit of gamification for those of you that are competitive out there. We've roughly at Team VMware contributing to the project just have over 1,000 active members today, and hopefully by the end of this presentation we'll add a few more. We produce the Fling to help volunteers easily get started to contribute their resources from their vSphere platforms, and currently we have around 42,000 downloads of the Fling. We can also call on our vendors and maybe even our competitors in Dell, Nutanix, Rubrik, Easty, Veeam, SunGuard AS, and many others, such as VMware partners and customers using our Fling today to contribute to our team or their own teams as well. And we're going to discuss about how you can also join our team and contribute. One of the questions that I'd like to ask if you want to get in touch with me directly is, how many of you today are using our Fling? And as you can see in this big column here, a lot of users that downloaded our Fling originally downloaded the original version, but never moved or downloaded to a newer version of the Fling itself. So again, there are some benefits and features and reasons to do that. If you're unsure, then please, at the end of the session, reach out to me as well, and we can chat about that too. As Pat mentioned, getting started is really easy. Just go to the foldingathome.org website. You can either start folding locally on your machine, which we'll cover in a second, or the more technical demo is going to be looking at running it on a vSphere platform. Running it on your local machine, as you'll see in a second, we just kind of access this through a local hosted website, and it just runs in the background as we need. Or we have that more in-depth OVA, and we'll also talk through some options available for managing this at scale. So I'm going to move into my lab environment now. So as mentioned, going to the website is going to show you the version for the operating system that you've loaded from, and you can see the vSphere environment as well. And I'm just going to click on the alternative downloads, and we'll come back to that in a few moments. Running on my local machine here, so this Windows server has the Folding at Home software installed. Today, I don't really need to show you how to install Nextfusable. We're all okay with that. But what you will be able to do is add an identity, link yourself to a team. You'll get some statistics that come through to help with the gamification side of things. You'll also get some really cool information, such as which project you're contributing your CPU cycles to. And the numbers displayed here really just kind of summarize the shard or the part of the protein that you're going to compute against as well. Proteins, we mentioned before, very complex items. You need a lot of CPU resources to compute those folds. So you will find that you will not get a single project item to yourself that is looking at the full protein itself. You're always going to get a small part of that. On our flings.vmware.com website, you'll be able to find the actual appliance folding at home itself. We've got a number of requirements listed. You can essentially run it on pretty much any version of vSphere that's supported today, or VMware Fusion or Workstation. We've got the OVA to download, full in-depth deployment steps, an FAQ as well for commonly asked questions, and if you want to go a little bit more advanced, we also have instructions on how to use a GPU as well. So I'm going to take you through a quick demo showing you how to deploy the OVA. It is pretty simple, to be fair. I've already loaded up the OVA from the Flings website just to save some time. We're going to deploy that virtual machine. So we'll give it the name of vBrownBag -FAH. We can select an area to deploy it to. And realistically, none of these options for deploying an OVA different to what you've been used to in the past. Just take a couple of moments to validate. And the first decision you need to make is the size of the OVA itself. So we've given you some basic guidance on what we found works really well with the appliance itself. And as I mentioned, the software is very CPU heavy. So you start off with 2 CPUs, 1 gig of RAM. A large machine is going to be 16 CPUs, 4 gig of RAM, but you can change the OVA appliance manually yourself after you've deployed it. 4 gig of RAM is the maximum you need for the virtual machine, but you put as many cores as you've got available to that appliance. Then select your location to deploy to, your network, and then you've got the OVA appliance settings itself. So we're going to provide the host name, IP address, gateway, DNS, the typical settings you expect for a Linux appliance. If you leave these blank, that's perfectly fine. We'll use DHCP for networking. We've got proxy settings if you go through a web server for whatever reason. Then we've got some mandatory settings. You're going to have to set this root password. If you do not set that root password, when the appliance boots and tries to auto-configure itself, it will fail. And you'll actually see a little login screen that says vghetto-login. Setting the root password then will actually show the host name that's set for the OVA once it's deployed and the first boot has completed. So I'm just going to set VMware 1 exclamation mark for this demo. I'm going to enable SSH so I can get to this machine remotely. I can set the parameters for the folding home software itself and link to my user account. We do recommend using a passkey. It's just an additional way to authenticate yourself. It's a unique key to yourself. But again, you don't need to set any of these options if you want. You can just contribute to the project anonymously. Set the mode in terms of how many cores of the virtual machine it's going to use. Because it's dedicated to OVA, I always recommend full. If you want to use GPU enablement, then you're going to have to enable it here. Set which networks can access the OVA appliance itself. And also set a remote access password as well. We also have the ability to show a top console for the OVA once it's deployed to see your environment. And then finally at the bottom, we've got some advanced settings around debugging and net unit percentage. Again, I encourage you to kind of read some of the documentation at home about what these settings do. Okay, so I've already deployed some virtual machines in my environment to save some time. And I'm just going to show you a virtual machine that's been deployed straight away. So in the web console, by default, we've got this top environment. I can see how many cores are being used. And at the bottom there, we're tailing the logs of the software. And we can see that I've computed 99% of this particular work unit that's been downloaded by the FAH client. One of the things I also want to show as well is we have the ability to download an FAH control software when you've deployed many appliances. If you download the Windows or Mac OS X client to run it locally as well, this software is included. If you're running on Linux, it is a separate download. Once installed, you just look for FAH control on your machine. It's a very, very simple interface. You will go in and add your client machine and the host, the IP addresses that it's booted on, or static IP address you've given, the port that you are interested in. So by default, this is, we use the default ports, there's no change there. Password displayed for the OVA deployment itself. And then your interface will look like this. We've got the same settings you actually see through that web interface, such as the project number and IDs we're working on. And if I open up the advanced settings, again, we can change the identity. So if you get something wrong, you can change it. The slots, this will be set for CPU by default. You're going to have to configure some of these extra settings yourself for GPUs. We've got the remote access settings, got proxy settings, some advanced, and we can even select which cores we want to dedicate to. I just choose for any disease that's available for any project. And then finally, expert settings as well. So we won't in this particular call go through in much detail, but we do have some answers in our Folding at Home FAQ on the Fling website for you as well. So I've really taken you through a whistle-stop tour of how to deploy the OVA and how to manage multiple OVAs itself. Everything else, you leave the software to itself. One of the things that I'd really like to call out, just by going back to the slide deck in my last 60 seconds here, is once you've deployed the OVA, sometimes you'll see that you get failed to connect messages in the logs, and this is fine. The Folding at Home environments have hundreds of thousands of users and millions of users during the COVID at the moment. And sometimes the work servers that we download the researchers' projects from and also upload the completed work units to can come overloaded. The software itself is designed to work in the background to continue to try and upload those files and download new work units as well. So I really recommend that if you're seeing this error message, don't panic, leave your software to continue running in the background. If you realize, that it's maybe going on for a number of hours or even days where you're getting nothing, then please reach out directly to myself over Twitter or through my blog, through the Flings website as an issue, or go to the Folding at Home forums as well for additional support. I'd really like to wrap it up there today with a final call to action. It's very easy to get started. Just go to foldingathome.org. And I'd also just like to end on some short links as well, so that you can go directly to our Flink website and also to the blog covering the common FAQ. Thank you very much for your time in listening to me today. It's been a pleasure.